How can I complete transformations of the exponential parent function y equals ab to the x using y equals a times b to the x minus h plus k form? So the h and the k are the key pieces for the first transformations. We got to remember that transformations are when we move or adjust a function's graph, kind of think about like transforming the graph and moving it around. And the parent function is kind of that base function we start with and move from there. So let's take vertical and horizontal transformations first. And that's where that h and that k come in. We're going to first start with adjusting the h value from nothing to 3. It says x minus h. So we're going to turn that into plus 3, which means we're really doing minus negative 3. So think about it like that, right? I substituted in, I made this table for x where I just put -1 in for x in both equations here. I got 1/2 and 4, 1 and 8, 2 and 16, 2, 4 and 32. And what I really should have done is continue this negative to show you what it would be so we could figure out when both graphs equal 1. That's the key thing here. And I put it on the graph so you can see that f of x, the y value is 1 at x equals 0. G of x, however, is 1 at -3, which makes sense. If x is -3, plus 3 is 0, so then 2 to the 0 becomes 1. And what it ends up being is a shift to the left 3 spots. It's the same graph, but it shifts to the left 3 spots. So we're looking at a horizontal transformation. Another horizontal transformation would be if instead of adding 3 to my x, I subtracted 3. So the minus h became just a value of 3. In this case, when I have 0 for x, f of x is 1. And when I have 3 for x, g of x is 1. And that's that key thing to look at in this graph, is that the g of x is 1 at 3 and the f of x is 1 at 0. So it's again a horizontal shift, but this time to the right. So when my h value, when I do minus h, and that h value is positive, meaning I'm subtracting an h value, then you're going to shift to the right. And when that h value is negative, which changes to adding, you then shift to the left. Now, the other type of transformation would be vertical. And we create that vertical transformation by simply adding to that k value at the end. So 2 to the x, 2 to the x, that stays the same between our two functions here. And we just add 3 here. So that's also going to change our horizontal asymptote. So if x is -1, f of x is 1/2, whereas g of x would still be 1/2 plus 3. So it's 3 1/2. X is 0, f of x is 1, g of x would be 1 plus 3, so it would be 4. X is 1, f of x is 2, g of x is 5. So in this case, you're actually never going to get a g of x value of 1. And if you graph them, you kind of see, because we have our horizontal asymptote is right at 3. And remember that horizontal asymptote is y equals k. So whatever that k value is, if that k value is 0, your asymptote is y equals 0. If that k value is 3, your asymptote is 3. So you're shifting, in this case, up 3 because I added 3. Again, it's plus k. And if you were to do minus k, you'd be shifting down. So here's our summary, right? Got a little bit erased there in moving the boards. So it's x minus h. So if h ends up being less than 0 or a negative number, you shift left. And if h is negative, when you substitute it in, you end up adding. So it changes it. Basically, if it's adding to x, you're shifting left. If it's subtracting from x, you shift right. So if it stays in this form, you shift right, minus h. Now, with the k is a little more straightforward because you're adding k. So if you add or increase k, you go up. If you decrease k, you're going to go down. So just keep that in mind. And so down is when you subtract from your original function. Up is when you add to the original function. Left is when you take that exponent piece and you're going to add to it. And right is when you subtract from the exponent. Or in this case, with the h value is going to be less than 0, goes left, and greater than 0 goes right. Another type of transformation where you have the parent function is 1/2 to the x, and then in the transformation I'm multiplying that by a factor of 4, and this is called stretching the function. And what it does is, for example, here's f of x, where if x is 0, y is going to be 1, because 1/2 to the 0 is 1. And in this case, if x is 0, you have 1, but y would actually be 4, right? And let me put that up in a different color for you. And what it does is, as you continue to go, like as x equals, say, -1, y would be 8. So as you get out, it kind of goes up a little bit faster and sort of stretches vertically, but then as you go down here horizontally, it does kind of sort of get closer to it there. Vertical stretch is what that's called when you multiply by a factor. And then a vertical compression is when you multiply by a factor here that is going to be less than 1. So in this case, the vertical compression is 1/2. So here's f of x equals 3 to the x, and this would be 1/2 of that. So when x is 0, you end up at 1/2. So here's 1. So here is where you would start. In this case, you're getting smaller, but it's still going to kind of mirror this and sort of get closer down there and get a little bit further away as it compresses it and kind of flattens it, squishes it, versus stretches it out. This one is a reflection. So the reflection is when you put the negative in front of it. Now be careful, the base here is not -3, but it's more so like I'm multiplying by a factor of -1. So here's f of x equals 3 to the x right here. And then if I'd said g of x is -3 to the x, well, let's put in 0. 0, x is 0, 3 to the 0 is 1. 1 times 1 negative is going to be -1, so there's my point there. And what you'll find is that this graph actually looks like a reflection directly over the y-axis. And sort of looks this should be just like a mirror, like if I folded this in half. That's kind of what that graph would look like there. So finally, what are these transformations? Let's sort of review them. Most of these I covered, some of them I did not. The vertical and horizontal is where you have f of x and you add k to it, or you do horizontal, you do f of x minus h. So you're going to slide whatever h value is. Remember, if h is a negative value, it actually becomes adding, which means you end up moving to the left. Vertical stretch or compression is when you have a, this factor, multiplied by your function, which I just showed you, the stretch or compression. I did not show you the horizontal stretch or compression. That's where you have a factor that's multiplied by the x that's in the exponent there. And then the reflection, I showed you the negative f of x, where you reflect over the y-axis. What I didn't show you is you could possibly reflect over the x-axis. Sorry, I think I misspoke earlier too. The negative f of x reflects over your x-axis, but you could reflect over the y-axis by putting a negative x into your function. And again, these are completing transformations of the exponential parent function y equals ab to the x using y equals ab to the x minus h plus k form. And that's how you do it.